Bulletproof Radio, a state of high performance.
You're listening to Bulletproof Radio with Dave Asprey. Today's cool fact of the day is that anxiety may be inherited from your parents' brain activity patterns. And researchers found a pattern of this brain activity that's tied to anxiety and traced it through generations of monkeys. The results of this large study of about 400 monkeys bring us a little closer to understanding severe anxiety and how it's inheritable. This came from the University of Wisconsin School of Medicine, and they say this new activity pattern really acts almost like genes going through your family tree. They measured anxious temperament by subjecting young monkeys to a stressful situation, and they measured how they responded to that situation. In other words, how strong of a response they had, and they measured their levels of cortisol, and they figured out which monkeys stress harder than other monkeys. And then they scanned the monkeys' brains under anesthesia. And the monkeys that had the bigger stress response showed a crucial difference in the extended amygdala, which is a brain structure and its surrounding that's known to be involved in fear and threat detection. Oh, and if you meditate, it's probably involved in some of the more esoteric spiritual states you can achieve when you train it the other way, but no one ever talks about that. That wasn't in the study either. But two parts in particular of the amygdala, the central nucleus and the bed nucleus of the stria terminalis behaved in lockstep in the high-stress monkeys. And this is through functional MRI scans. And they found if your parents had it, the kids had it, along with that anxious temperament. What this means is that you can blame your mom for your mitochondria, but you can blame both of your parents for your anxiety. Either that, or maybe you should just do some basic forgiveness and all that stuff and be done with that crap, because you can retrain your amygdala. They didn't put that in the study either, but that's been a big part of my path to being not an anxious jerk. All right. Now, I typically like to foreshadow, and you can wonder, am I going to be talking about monkeys, fMRIs, or anxiety? In this case, well, none of the above, and maybe a little bit of the above, because we are talking about neuroscience, and we're talking with a leading Bay Area-based Ph.D. who studies comparative neurology to understand our brains and brain evolution. And he's doing this at Stanford School of Medicine, where he's a professor of neurobiology, and he's made a bunch of important contributions to the field of brain development, brain plasticity, neural regeneration, and repair. So, of course, that's why I want to talk to him. We're talking about none other than Dr. Andrew Huberman. Andrew, welcome to the show.
Thanks so much for having me. I'm thrilled to be here.
Now, if you are a fan of neuroscience, which is pretty likely if you've been listening to the show for a while, we're going to define all of our terms as we go through the interview. If you didn't know what the amygdala was, that's okay. Now, Andrew, you know, like so much cool stuff. I almost didn't know where to start when I'm thinking what I ask you, because you talk about increasing cognitive capacity, which is really cool. And you've done some really crazy martial arts and scuba diving. Like you're a very fit neuroscientist, as opposed to, you know, the thick glasses, white lab coat, and overhanging belly. That's probably the stereotypical neuroscience guy. So let's start there. What's up with increasing cognitive capacity by leveraging your stress and arousal system? Like, what does that even mean?
Yeah. So I've long been interested in perception, cognition, all of neuroscience. And the short history of this is the following. So really there are 5 components to how you go through life, and only 5. And they are the things you sense, right? The things you perceive. So which of those sensations you're focused on.
So you could sense something, but you wouldn't consciously know you sensed it, you're saying?
That's right. So I could say, you know, right now you're sensing the bottoms of your feet in contact with the floor, but until you think about it, you weren't paying attention to it, you weren't perceiving it.
Correct.
But you're sensing things all the time. You can't turn off the sensory epithelium, as we call it, the sensory sheet of your eyes and your ears and your nose and your mouth and the rest. You're sensing things all the time.
But you can turn those off with either lidocaine or LSD, right?
Yeah, those are pretty extreme circumstances.
Okay, but I'm saying, but when you do those, weird stuff happens. Like anytime you walk around going, I can't feel my hand, or I can't feel my face after, like those are extreme states that everyone remembers because they're so bizarre, right?
Yeah, I mean, you could amputate a limb too, but
That's a good point.
right. So I guess I'm referring to the sort of like basal states of
Okay,
like
the normal states. Okay.
I don't mean to be nitpicky, but that's yeah. So you're sensing things all the time, and then there's what you perceive, which is what you're focused on, and then there are your emotions slash feelings, and I'd like to call them emotions, not feelings, because when you call them feelings, they're sometimes confused with sensations. Because the feel part, that's just a semantic thing. And then there are your thoughts, which are interesting, and we can talk about a little bit more. And then there are your actions. So that's it. You've got sensations, perceptions, emotions, thoughts, and actions. And that's essentially all your experience. And of course, you're engaged in those simultaneously to varying degrees at any time. And then there's this thing that they all ride on, which is your level of alertness, or let's call it autonomic arousal. Some people like to call it stress, but that gets a little tricky. Let's just call it autonomic arousal. Here's what I mean by that. When you're dead, you're not going to experience any of those things, as far as I know.
Right.
Never been dead, so I don't know. Now, as your alertness, let's say you're fast asleep, you're sensing things, you're having thoughts. They're not very organized most of the time. You can even have feelings. You can have emotions within sleep. We know that. And you have very limited behaviors unless you're a sleepwalker or something like that. But as you become alert and calm, more of those things become available to you, like deliberate conscious thought. And or feelings about your morning, the people in your life plans, your past, etc. As you become more and more, some people like to call it stress, but as autonomic arousal goes up, the weights of those things and what's available to you shifts dramatically. So your ability to engage in conscious, deliberate thought goes down as autonomic arousal reaches peak levels. So if you're in a panic, it's very hard to think about things in an organized way.
This is like the stuff Lieutenant Colonel Grossman, who wrote On Combat, was just on the show, and he talks about at the very extreme states how even soldiers, like, they just go to training because they can't think, they can't do any of that stuff. And you're saying even as you approach that, your cognitive abilities goes down as your stress levels go up.
That's right. And if I look at the whole of wellness or biohacking, and there are tools that are designed to control autonomic arousal that fall into different categories, like the ones that are designed to raise your ceiling on what you perceive as stress, ice baths, hard runs, these kinds of things. There's a whole galaxy of those, as you know. And then there are the ones that are designed to bring your stress level down once you enter the stress response, to kind of tamp it down consciously. And then there are the ones that are sort of designed to bring your state up. Wim Hof breathing comes to mind. Yep. Oxygen-dominated breathing. We can get into this in more detail if you like. But in any case, in thinking about brain activity and life experience in this way, I became interested in the following question. So I'm classically a visual neuroscientist, meaning that my lab studies visual perception and the nerve cells and connections in the brain that mediate visual perception, because we're just such visually driven animals. About 40% of the human brain is devoted to visual processing in some way, as well as merged with other sensory modalities like hearing. But I was interested in why some visual stimuli create anxiety or increased autonomic arousal, and some perhaps, and we could get into this, actually decrease autonomic arousal and potentially could be used as stress management tools that are very fast and in real time.
Do you mean, when you say visual stimuli, do you mean like flashing lights or pictures of zombies or something? Like what are we talking about?
Okay, yeah, great. So if you see a picture of something that frightens you, even if you don't have a phobia, your autonomic arousal immediately spikes. Yeah. We're all familiar with that. There are things like light exposure, overall light exposure with no form whatsoever, what's called just ambient light, like the overall level of ambient light delivered early in the day will increase your autonomic arousal. It will actually increase alertness. There's a very powerful circuit for this. You know well about this. And that's the circuit that you want to avoid triggering late in the evening, which is why you might wear blue blockers or something to avoid looking at your phone in the wee hours.
Right.
So light and visual stimuli have a powerful control over autonomic arousal. And the nice thing in a scientific sense about vision is you can completely control what are called the statistics of a visual scene. So whereas like showing somebody a zombie is kind of a complicated visual stimulus, in some ways it's actually very simple. I know exactly where the lines are in that image. I can make them different contrasts. I can make them different speeds. I can give them more or less reality, depending on how I contour them. All of this is to say that a few years ago, I decided to start addressing stress the question of what is stress in the brain? What are the circuits? What is the potential for the visual system to be used as an intervention for stress management, both preventing going into the stress response as well as managing the stress response once you're in it? And that brought us to an interesting question, which is the one that you asked, which is, how is it that autonomic arousal, which I can modulate using the visual system, and I can get into that in more detail if you like, how is it that autonomic arousal allows someone to process more information or less information? Is there a sweet spot in which being alert and maybe even slightly more in the stressed regime actually allows me to process information better and faster? And here's the experiment that we did that led to that hypothesis, essentially. A student in the lab, Ph.D. student, was looking at the fear response in mice, just letting mice run around in this little empty aquarium, no water, and then showing an expanding black disc above them. And that essentially mimics their experience of an incoming predator. And so mice will do one of two things, and they'll do it the first time and they'll do it every time, and they don't need to learn it. They'll freeze or they'll run for shelter. Okay, so mice are innately, just naturally afraid. They'll freeze or run for shelter. Now, she mapped the circuits in the brain that mediate that response, and then she started increasing or decreasing the activity of these brain areas. She found an area of the thalamus, which is just kind of this egg-shaped thing in the middle of the brain, called the nucleus reunions. This is a very poorly understood area of the brain, but it connects to the frontal cortex. And here's what was interesting. If she increased the activity of this brain area that connects the thalamus to the frontal cortex, and she showed the animal a fear-inducing stimulus, the animal would confront the stimulus. It would no longer freeze or hide. It would literally walk out to the stimulus and rattle its tail, which is the mouse equivalent of beating its chest and saying, okay, let's go, let's fight. And if she turned off that structure, the animals became more fearful.
And how was she turning that on?
She was using one of two techniques. One is called chemicogenetic, where she actually puts a virus that on its own doesn't really do anything bad, but that carries a receptor, it's a muscarinic receptor, that she can inject a drug to either silence or increase the activity of the structure. This is going to be the future of gene therapy in humans, things like this, not that exactly, but right now you only do that in mice. But I'll talk about the work we're now doing in humans. That's
so incredible. So just tuning that part of the brain. And I recently did transcranial magnetic stimulation of individual brain structures. You could probably hit the thalamus with that. In fact, I even have some gear here that does it with magnets at a lower amplitude than the $250,000 gear that they're using at the psychiatrist's office. But
yeah, it's coming.
Wow.
Manipulations of brain circuitry are coming. And so this is a circuit that literally changed fear into courage. And so we asked, what's going on here? And so it turns out that this circuit allows the animal to bypass the amygdala activation. I know you mentioned amygdala in your intro, to bypass amygdala activation and instead to engage the frontal cortex. Now, that was all fine and good, and we were excited that we discovered that circuit. But the really interesting part was when she explored the level of stress in the animal when it was engaging in these so-called courageous or confrontational responses. The autonomic arousal measured at the level of heart rate and breathing was actually increased. So we think of courage as this kind of calm state that allows you to, engage in challenge without experiencing fear or negative emotion, but it's quite the contrary. And we know this because if someone were attacking you, your level of autonomic arousal or stress would go through the roof. But if I just got a snapshot of your response to that, you're going to fight back, right? Whereas if they're just following you, you might hide or get into your car and leave. So the fear response is actually the lower arousal response. And that was all fine and good and interesting. But then the third thing that she discovered was really what blew our minds, which was that when we did an experiment to ask the animals, and of course mice can't answer, you can ask them all you want, but they won't answer. We did an experiment where she stimulated this brain area when the animals were on one side of this little chamber or the other, this container. We found that they preferred the stimulation side. They love stimulation of this pathway. So this confrontational or courage pathway is actually directly linked, we discovered, to the dopamine reward pathway. And it means that successful confrontation of fear, meaning not dying, not getting eaten, not doing something stupid, but successful confrontation of fear involves increases in your stress and is heavily rewarded in the brain. So much so the circuitry is forever changed after that. So this was a paper that we published in Nature in 2018, and it immediately prompted us to say, okay, we have to do this in humans.
Well, we do it in humans. Maybe not that exact study, but one of the things, Tony Robbins walking on coals, right? Like you feel like you're going to die, and then you step on it like, oh, I did it, and it changes your brains. Or you look at like the flow genome stuff, where one of the ways to go into a flow state is, well, just almost die on a mountain bike doing 50 miles an hour or skis or something, and you get that dopamine hit and you go into this altered state. So it seems like we know that there's a reward system because we can see it in certain behavior patterns like that. But are you actually able to measure that in humans now?
Yeah, so we immediately built up a virtual reality laboratory that looked exactly like the mouse laboratory, except bigger, of course. And this prompted us to go collect the most realistic fear-inducing or arousal-producing stimuli that we could for VR. So that was what led to my collaboration with shark diver photographer Michael Muller and doing cage exit shark diving and recording great whites to bring back that footage to the lab and build VR experiences that are very realistic compared to most studies of fear. The history of of studying neuroscience fear in humans is, in my opinion, has been a little deprived, let's say. But VR changes that because you can control everything within the VR. You can look at where people are looking. You can measure where their eyes are. You can get subjective reports. You can measure their breathing, their heart rate. But the real twist in all this that made it exciting was we teamed up with a neurosurgeon at UCSF, a guy named Eddie Chang, a spectacular neurosurgeon, to actually record neurons from the human brain, both the amygdala, the visual cortex, structures like the insula, to actually get measurements of what the brain is doing in humans while people are going through these fear, confrontation, courage versus freezing versus, types of scenarios. And what it's taught us, and it's still early days for the human work, I should mention. That work isn't published yet. But what it's teaching us is that the capacity to maintain cognitive load, to perform a cognitive task under conditions of high stress and arousal, you can train this up. You can essentially access and produce more cognitive information. You can basically think better. Let's just put it in plain language. You can think better and do better in a complex game or in a simple game when your autonomic arousal is higher. And so I'm very interested in this because I know there are a lot of people walking around that are really stressed and people who are traumatized, and that's terrible. And certainly everyone should deal with that through the appropriate channels. But there's this real question, like, what was autonomic arousal designed to do? Well, autonomic arousal was designed to leverage your behavior. It was designed, once you got hungry enough, you were supposed to get agitated enough that you went and sought food.
When you say autonomic arousal, you're talking about sympathetic, like the fight or flight response being turned on enough, not the sympathetic branch, not the parasympathetic branch, the rest and reset branch of the autonomic system, right? You're talking about being a little stressed enough to do good work.
That's right.
Okay.
I'm talking about why. Here's my theory. I'll try and weave this with some of the more common daily practices with people who don't have electrodes in their heads. I've always found that a little bit of, for me, just myself, a little bit of mild hunger, or like the intermittent fasting thing, or the kind of ketogenic oriented nutrition, always sharpened my focus. Back in 2005 when I was a postdoc at Stanford, I got teased a lot because I would drink the oil off the almond butter, and everyone was like, "Oh, gross." I could work very long hours that way. I always liked, when I was working long hours, to maintain a little bit of sympathetic tone, as they say, be a little bit more on the stress regime. And when it's time to relax, you can eat some starches and crash out. And so the nervous system is highly susceptible to these kinds of manipulations because you have to remember that, of course, and the autonomic arousal, like even the stress that people feel around loneliness, that was installed in you to get you to go find a mate.
Oh, totally.
Right. And if you are not lonely, like you have a mate and you've mated recently, then there's a period of time, it varies between individuals, where you're content to be relaxed. It's parasympathetic dominance because nature. So you're being you're being manipulated from the inside based on what nature wanted you to do, but you can leverage that. That's the power of that fourth element, which is conscious thought. And so it occurs to me that there are two states that most people want to be in. not 50. There are psychedelic states and there are other kinds of states, flow states. But the two states that I think most people seek are alert and calm or asleep. And I feel like one of the beautiful and exciting things that's happening with this biohacking movement and with the wellness movement and is to find healthy, sustainable ways to be alert and calm when you want and asleep when you want. And if you're not good at it, to get better at it. Yeah. And so while the lab doesn't work on those things directly, I'm just fascinated by the extent to which autonomic arousal can be used as a tool to get you where you want to go.
It makes so much sense. It's funny because one of the things that I was kind of embarrassed to put in Game Changers, there are 4 laws for high performance around sex and relationships. Because it's one of those big 3 things that every cell in your body is wired to do, right? Like even single-celled organisms, if they don't have sex or they don't reproduce in some way, the species will end, right? So we're kind of wired. But I found there really is an orgasm hangover, at least for men. And it has to do exactly with that arousal system. Like there's a couple of days where you're just relaxed, but if you wanted to get stuff done, you actually don't get stuff done the next day. You're a little bit more chill and maybe a little bit less satisfied with life because you're like, I got nothing to do today, sort of thing. So I published a year's worth of data just on that, which that was the embarrassing part. But what you're talking about, there's the neuroscience behind that. So you're saying if you don't eat for a little while, not for a long period of time, you might perform better. The intermittent fasting, boom, there you go. I would say if you don't eat and you have some extra ketones from, say, bulletproof coffee in the morning floating around, you're probably going to get even more of that, right? But if you go on, the number one thing, though, that we're all wired to do is run away from, kill or hide from scary things. And you're saying having enough of that even is cognitive enhancing. But all right, I'm sitting here, I'm completely vibing with everything you're saying. How exactly am I going to get more of that first, the first F word, the fear F word, as opposed to the food F word? How am I going to get more of that without being at risk of breaking limbs and getting TBIs and things like that?
Yeah, I mean, I think one of the things that the flow genome guys have really spelled out well, I went and saw one of their things recently, is, this idea that, you want it, they have this list of kind of suggestions. They don't call them commandments, but one of their suggestions, and I don't work for them, but I'm friendly with those guys.
Yeah, I was the first investor in the flow genome project, so I've been doing it for a while, yeah.
Yeah, I'm excited about what they're doing because they're putting things into a really nice framework, which is, you definitely don't want to end up like in a body bag or in jail or do something stupid.
It's always my concern about like just do high speed skiing and,
not for most people.
Yeah.
It's not for most people, and you can die, and people do die. And I worry that, the threshold for that, especially with YouTube videos and all that, and, that I watched and enjoyed Free Solo, but that's not something that most people should do, right?
Yeah.
So you have to, make a very thorough assessment. So the threshold is different for everybody. But what I would like people to appreciate, and I think certainly you do, is that some level of an understanding about what the stress response is really for reframes it from a pathology that we're supposed to run from and control at all costs to something that you can think about developing tools for. So I think of tools in terms of real-time tools and offline tools. So if the work that we're doing now, we look at both so-called normal subjects and subjects who have generalized anxiety. And again, it's early days, but what we're finding is that one way to measure or evaluate, as well as potentially control the stress response in real time, is by altering the way in which literally you look at the world. Now, here's why. So the visual system has a powerful control over your level of autonomic arousal. So you have to think about which direction you want to go. So let's say I'm alert and kind of sleepy, and I'm not motivated or engaged. There are times when I'm not stressed, I'm kind of under stressed, and I need to lean into work or do something. There are a number of ways to do that. Of course, many, your listeners know them, and you have many of them. They're powerful. But we have 2 kinds of vision. One is panoramic vision, so-called magnocellular vision, because it's carried by big neurons that transmit information very fast. And it's designed to view the world in kind of panorama. So if you dial out your gaze as you're listening to this, or and just kind of see yourself, but see yourself in the entire room, or even better, if you're outdoors and you just see everything, the world kind of takes on a spherical shape. That's associated with a branch of the visual system you're engaging a branch of the visual system that is more sort of parasympathetic dominant. It actually is, animals that are grazing animals only have that system. They don't have what's called foveal vision. They don't have high acuity vision. They're grazing, and their only concern is to get their food while detecting if anything comes into their environment. It's actually a system that allows you to process information much faster because the neurons are big for potential threat detection, but it's a low anxiety state. Now, there are many yogic practices that are kind of associated with soft gaze and things, but this is the neuroscience of that. And you can do it by dialing out your gaze. By contrast, when you focus your eyes on a single what's called vergence point and you enter foveal vision, you're now switching to high acuity vision, and your perception of time switches. This is what's key. You're altering you start micro slicing time. So big picture time bins are bigger, small picture time bins are smaller, just simply by virtue of the two parallel circuits that we have in our brains, primates have in their brains, lions have in their brains, but animals like sheep and cows don't. They only have that panoramic vision. So we've been exploring in the lab the extent to which you can use your states of viewing the world as rapid ways to enter and adjust your level of autonomic arousal. So when I'm kind of sleepy and I need to focus and do work, I actually focus on a crosshatch about a meter away for about a minute, and it actually acts to lock my attentional system. You can actually, there's a blip, a kind of increase in autonomic arousal that goes up with that. And then I personally find it easier than to focus on a work task. Conversely, if I'm sort of in a stress state, people always say, okay, control your breathing. I'm a big fan of breath work as a way to control your breathing.
Oh, yeah.
But the problem is it's closed loop. So if I'm really stressed and I can't control my breathing, then controlling my breathing isn't an option. But dialing out, it's also not covert all the time. You can't do it in every circumstance. Can't do it if you're scuba diving. You can't do it sometimes you should, but adjusting breathing when in real time is a complicated thing because you don't want to compromise your activity. But you can dial out your gaze and very rapidly adjust down your level of autonomic arousal. In fact, the visual system is the fastest way, maybe the auditory system as well, to downregulate your arousal. And the reason for that comes from neuroanatomy. So here I teach neuroanatomy to the medical students, and there are multiple cranial nerves that feed the so-called reticular activating system, this wake-up system for the brain. But the two that people often overlook are cranial nerves 2 and 8, which are the optic nerve and the vestibular auditory nerve.
Wow.
So if you recall, the optic nerve was the primary evolutionary anciently installed mechanism to control arousal. And now you consider that the human brain is 40% for vision, and now it makes sense why, okay, of course you want to block blue light in the evening because that optic nerve, that second cranial nerve, is carrying arousal information to the brain. And if you stimulate it with blue light, which it's susceptible to in the evenings, of course, too strongly, you're going to shift your clock. So our ancient brain used vision as one of the primary drivers for controlling autonomic arousal.
It's interesting. When I went through this period, this must be about 10 years ago, where I was working with a developmental ophthalmologist. And he had me do all sorts of crazy exercises that over the course of 3 months, I went from 20/60 in both eyes back to 20/15. And I got rid of astigmatism. And to this day, I'm still 20/15. And I had drifted. So I was like 20/60, 20/80, something like that. So it was kind of magic, but it was an hour of weird vestibular activation exercises. I was exhausted for the whole day after I did these. Like, it was really terrible brain stress, to be honest. But one of the exercises that made the biggest difference, and something that I'll still do today if I need to, is like you rub your hands together, like the way you would like in Qigong, and then you cup them over your eyes and just open your eyes, but all you can see is darkness. And if you talk to Dr. Barry Morguelan, the Chinese energy master UCLA surgeon who's been on the show a couple times, he's like, well, there's special chi that comes out of rubbing your hands. But you talk to a neuroscientist like you're saying, well, covering the vestibular system allows the brain to relax and allows the eyes to relax and maybe is triggering that relaxation system. So I've taught people to do that for anxiety, but I think you've got the mechanism for what's happening there.
No, it makes perfect sense.
Okay.
I mean, I think that, I don't shy away from the notions of, yoga or meditation or,
Yeah.
this is the area, right? So it's
Hold on a second. Can you be a modern neuroscientist and just completely dismiss all that stuff? Like, has it shifted
well,
that far?
well, it's interesting because, I mean, people vary. My colleagues here are very open-minded. I mean, people vary in the extent to which they do these things. I think there's a new generation of people coming up who were exposed to ideas, who realize that their nutrition impacts their health. I mean, I've been very
Or
sad
their
to
brain.
yeah, I mean, been very sad to see colleagues who didn't manage their health well. Here at Stanford, people tend to be pretty health-minded, but who didn't manage their health well, who were understood. Some of them were studying cancer of all things, right? And so you see this where people who study psychiatric illness and then commit suicide. I mean, it happens, and the reason is that we're all myopic, we're all nearsighted in some way. We all have our blind spots. I think that what's so exciting nowadays is, and this is something I care very much about, is that the field of neuroscience is in a position to bridge in a logical, rigorous, and yet open-minded way to the fields of wellness and these more kind of what used to be niche fields like yogic practices and things of that sort. I mean, it can't be overlooked. And one reason why I love running my lab so much, and one reason why I also am so interested in these fields of wellness and biohacking, is because I think growing up in this area, I really got to see how computer science and engineering and physics that was once the domain of academics eventually made it into companies like Apple and Google and all these incredible companies. And I think the same thing is going to happen in neuroscience. I think it's happening now. It's starting, where the career options and the paths that these really smart, hardworking scientists and really smart, hardworking people in the wellness communities are going to start to merge through. And I'd like to serve as a bridge as much as I can for information and other ways to keep the flow of information bidirectional.
Andrew, you said something really important there. You said a lot of researchers or physicians or academics, that they're blind to, or they're myopic, or they're blind to certain new ideas. You've actually spent probably more of your career than anything else actually studying real blindness. And you actually said, I plan to give my entire life to the study of the visual system in one of your interviews with the Glaucoma Research Foundation. Mm-hmm. So you're like one of the top eye-brain interface guys out there, and you're actually working on curing blindness. Why do you care so much about blindness? I
think it's because we're just such visually driven animals. I mean, I love music, but if you took away my hearing, I'd be all right. Smell, I could do without. We have all these wonderful senses. Touch is obviously key, but we're just so visually driven. And I think it was early on, I was raised in visual system neuroscience, meaning my graduate advisor was in the lineage of these two guys, David Hubel and Torsten Wiesel, who won the Nobel for discovering critical periods. This idea that your experience during particular phases of life dramatically shaped the brain. It's like, duh, now, but in the early 80s, that wasn't necessarily, it certainly wasn't known. It wasn't data supported. They did that. So they're my scientific grandparents or great grandparents, but I've always been fascinated by vision. I grew up with a kid. He went to our school, this kid Tony, and he walked with a cane. And I remember having a very strong emotional response to that. It was just so clear that he wasn't going to be able to do most of the things that anyone else was going to do. And I think it hit me at kind of a gut level. I never knew that I'd get into visual neuroscience, but I know I felt how important the problem was. And then later, my lab was working on development of the visual system. And I thought, well, this is great, but we got to apply some of this to regenerating the visual system. So there was a wealth of knowledge from our lab and other labs on how the eye connects to the brain and vision takes place. And I felt like, look, the time is now. So we published a paper back in 2016 showing that specific patterns of electrical stimulation using screens, not wires, but having mice view particular patterns of visual stimulation could actually enhance regeneration after a blinding injury. And that I got contacted by hundreds, now thousands of patients around the world. Like, can you help me? Can you help my kid? Can you help my wife? This is so debilitating. I'm losing my vision. And so what I decided at that point was this kind of the typical line of, it's going to be 5 or 10 years before we do this in humans, more studies in mice. I thought, enough of that.
If you're blind, more studies are not needed.
Right, exactly. Right, exactly. So I thought, what is a safe and non-invasive way that we can bring this to humans now? So one of the things I'm most proud of is, and this was a team effort, of course, and I rely on excellent people here at Stanford and elsewhere, but was to take the timeline of running, taking a result like that to a clinical trial in humans. Typically it's 5 to 10 years, and we made it 10 months. So right now we're running a clinical trial with the ophthalmology department here at Stanford, where there are patients, it's a small number of them still, but we're growing that number, who have VR headsets that they put on 5 times a week for a 30-minute training, so to stimulate the retina in specific ways in order to try and get enhanced vision, so that they can see better. And for people who are losing their vision, and this is key, for people that are losing their vision, to not lose their vision. So to hold on to what they've got, because it's one thing to cure blindness, to reverse blindness, but in many blinding diseases, it's slow. So like in glaucoma, it's really slow. And so we are making a serious effort to halt their vision loss. And I can't, it's a clinical trial, so I can't report the results of that. Yeah, I'm also blind, no pun intended. I'm also aware of the results in many cases in order to keep the science rigorous. But it's, I'm excited about where it's going. I'll just say that. And of course the data were the data, but I
gotta ask you
so much about it. Yeah.
Do you go home at night and put those VR goggles on to give yourself supervision?
No, but I've become very, no, I don't do that.
Can I?
Yeah.
Will you hook me up? Hook a brother up?
Sure, I can hook you up with the code, and the stimulation is actually kind of fun. We have people forage through a virtual art gallery, so you can learn art while you do this.
Wow.
You have to make this stuff interesting. If you're going to do something 5 times a week for 30 minutes, we had to make it interesting for the patient. So we designed a virtual art gallery that the patients go into. They view these empty frames, which are boring, but then they see specific patterns of visual stimulation, and then as a reward for that, they then get exposed to they see these different paintings, and they're learning the paintings. And and we're using that as a measure of their visual perceptual abilities too. So,
wow.
Yeah, I'm happy to tell you what we're doing with it, supply you with what we've got. We're the VR technology has expanded so fast. I don't think VR is going to be one of these things that is going to take over every industry like people predicted it would. But I think for clinical treatments, it's extremely valuable.
One of the things that fascinated me when I got really into my visual system was that my left eye would actually turn off. So I would not see in stereo vision, but I didn't know it. I was blind to the fact that this was happening. So my brain would get tired. My visual system was stressed. My eyes didn't team well. So I worked really hard on turning that eye back on so that I would have both eyes working at the same time, and really training the brain to cause them to work together. The theory that they came up with was that, I started reading when I was 18 months old, so I probably spent a lot of time staring at a page instead of looking at trees and crawling around and stuff.
Yeah,
Who knows?
well, absolutely.
Yeah.
Wait, how old were you when you did this retraining?
I was about, probably 34, I guess, 33, 34.
So I mean, that's an amazing story, and it's awesome because the classic thing, the Huberman Weasel Nobel Prize, was for this idea that the brain is plastic early on, and then it's kind of frozen, these critical periods. But the work
Eric Kandel came on the show, the guy who discovered neuroplasticity. Right. So
yeah, no, I mean, I think that one of the great sequels to that was these people like Kandel, like Eric Knudsen, like Mike Merznick, who've shown that it's an absolute no. It's not just restricted to early life. That if you pay attention to the task that you're focused on. So this is getting to the realm of adult plasticity. If you pay attention to the task and you have sufficient level of autonomic arousal or alertness, right, sympathetic arousal, then the neuromodulators dopamine and acetylcholine, nicotinic receptors are stimulated by the acetylcholine. We can talk about nicotine, all right?
Yeah.
You're a fan under certain regimes. Then you open up plasticity. You essentially amplify the conversation between particular neurons that are involved in that sensory event, like viewing something or conversation or whatever it is. And then you get long-term plastic changes in that circuitry. And I think nowadays in 2019, it's absolutely clear that adult plasticity is not only possible, it's available. You just provided you engage in the particular learning bouts. They have to be short, they have to be focused, they have to be repeated. And it does help if there's some neuromodulator augmentation. Now, that's not for everybody, right? I personally believe not everybody should be chewing Nicorette or whatever, but there are
absolutely
conditions,
not.
right? But there are conditions in which that can potentially enhance plasticity. As you know more about that topic than I do, but the plasticity in adulthood is very real, and you're a really great example of that.
I'm really interested because I'd love to put on a pair of virtual reality goggles and like have it overweight my left eye to like stress that part of my brain so it would become probably even better than it is, because I know that I have a perceptive weakness there. And I imagine a substantial number of people have one eye that's a little bit weaker than others. We've had Helen Erlin on who talks about this stuff. So I know we could do that with VR, and I'm hoping that you or some of your friends are doing that. But the flip side, I'm a computer hacker by background, by training. And I think about what happens if you have malware running in VR goggles. Can I change the flicker rate on just the left eye versus the right eye? I mean, could you like trash people without them really knowing it?
Yeah, I mean, if someone had ill intent, they could do that. Sure. I think
that's actually kind of scary. I mean, if you're playing video games with
scary.
VR for 6 hours a day and there's a 5% tweak between your two eyes, over time, that could be like a substantial performance improvement and you would have no idea why.
Right. Well, I don't think anyone should be spending 6 hours a day in VR. I mean, Jeremy Balinson, a colleague of mine here at Stanford, wrote this book, Experience on Demand, and he's been in the VR field essentially longer than anybody that I know. And he has some very specific prescriptions, especially for kids whose brains are very plastic, because there's, look, 1 hour or 2 hours of a patched eye of just occluding or closing one eye in childhood can lead to a permanent shift in the brain representation of that eye. You can become cortically blind to that eye unless you do the reverse experiment, which is to cover the other eye and open the one that was recently closed and reverse it. That's the kind of work that Huberman Lab won that Nobel for. So the rewiring that you can have in adulthood is more subtle in any one session, but that's why you don't want to be spending 6 hours a day in VR or it's not clear you should be doing 6 hours a day of any one thing in particular, except maybe sleep, right?
All right, there you go. I like that quote. What about, we'll just call it human augmentation, about going beyond what we were born with. You've done your scuba, you've done some pretty extreme sports sorts of things over the years. What's your take on it? Is it real? Is it happening already? Is it going to happen? What does it look like?
It's going to happen. It's happening. That there are some people out there that are, claiming they're going to, put chips in the brain, get people learning languages in a few days, enhancing, Here's the deal. At this point in the sort of history of neuroscience, we understand a thing or two about sensation, the neurons involved that mediate sensation, a thing or two about perception, a thing or two about emotions, although emotions are very poorly understood, frankly. Yeah. A thing or two about thoughts, although that's very poorly understood. And action, we know a thing or two about because you can measure it, right? Now, that means that, what the brain is doing, the so-called neural code, is mysterious. So there have been a lot of recordings from the brain, so-called, when people say reading the brain, you're sort of like, what are the signals? When are the neurons active in space and time during a behavior or a thought, et cetera? And then there's writing to the brain. There's actually manipulating the neurons and their activity. Well, we don't know what the algorithms are that lead to if I say, okay, have you ever had a pet, Dave?
Oh, absolutely. I have a dachshund named Merlin.
Cool. So like just that conscious recollection of his name and his or her name and the ideas of Merlin, there's so much context, right? We don't really know what the symphony of neuronal activation is for that, such that we could manipulate it and change your relationship to it. The things that we're getting good at as neuroscientists and as biohackers or are manipulating that arousal state. I'm fascinated by all the stuff, all the concentration on breath work and ice baths and ketogenic diets. All this. These are all things really designed to manipulate arousal state. And then you've got the stuff that's more targeted at cognition per se, like nootropics and things of that sort. Is really more your wheelhouse than mine. But I watch the field and I try and place it in neuroscience context. The people that are talking about creating super beings that can learn so much and retain so much, I invite a challenge. I'm delighted that people are thinking about neuroscience, but without any understanding of really how to think about emotions in a rigorous scientific way, or think about thoughts in a rigorous scientific way to really understand what those are, I'm not all that confident that people know what sequences of stimulation to put into the brain in order to get it to be 10x better or 50x better at any one thing. However, I will say this. Things like you mentioned TMS, there are laboratories that are now using 10 hertz stimulation, not inhibition or inactivation, but activation, 10 hertz activation of particular circuits to open up the window for plasticity.
With magnets or electricity?
With TMS.
With TMS.
Yeah.
Okay. So I have a neuroscience facility, not quite up to the Huberman Lab standard, but we have 2 neuroscientists and a lot of EEG stuff, but we'll actually use very specific frequencies with an alternating current across the brain, including 10 hertz as one of them. But we'll do that to increase neuroplasticity before doing neurofeedback so that you can get basically more results in less time. Right? And I've been doing that kind of stuff. Well, the alternating current for now going on 20 years in different frequency sets. But you're doing it with magnets, which we'll also use pulse magnets actually in those frequencies, but they're very weak compared to what you're talking about. I'm a little frustrated. The Russians started doing this in the 60s. That's how come I know about it. It was from the Russian space program. And it feels like transcranial stimulation, TDCS. About 8 years ago when I started blogging, I wrote a lot about how to do it yourself. I've sent it out in the quarterly curated box I do. And I look at that. Biohackers are doing that one thing, but we have 50 years of using electricity or in some cases magnets on the brain, but it's almost unheard of. You got Halo Neuroscience out, maybe doing it. Why does it take 50 years for this stuff to come out? Do you have a sense from the inside of academia?
Yeah. So I think, so there are people using 10 hertz stimulation trying to open up windows for plasticity. It can be done. Why? Okay. The reason is that failures in neurosurgery and in medicine can halt fields entirely. So like if you look at gene therapy, right? Like there were some early failures that set back the field of this powerful thing of gene therapy, of using viruses to deliver genes that people need into their body and brain in different ways, set it back a decade or more. That there's the medical community is very reactive, right? Like the fen thing, like people were losing weight and then people start dying. It's like gone, right? It's off the market. Right. So tryptophan, right? It's like now you can go buy 5-HTP or tryptophan at your health food store online at Amazon. But, it used to be that because of a contaminated batch of tryptophan and some people died, it was like tryptophan was off the market, so people are relying on heavier sleep medication when they probably didn't need to. So there's a tragedy as a result of that ban, right, too. So I think people are reluctant, but it's changing. I think that brain-machine interface is going to be the first place, non-invasive brain-machine interface.
Can I high-five you for that? So the non-invasive part of that, if you're listening, there's the Elon Musk neural lace idea where we're going to have these implants in our brains. My wife, Dr. Lana, and I started a company that did lab testing for immune rejection of implant materials that are supposed to be hypoallergenic. And so we went kind of deep on that. This was in the mid 2000s. And I'll tell you, there are people allergic to titanium, allergic to gold, things that you're not supposed to be able to. And then you have biofilms and infection. And I'm pretty out there. I mean, I've had stem cells everywhere and done all sorts of stuff that I swallowed electrical stimulation devices. But I'm not implanting crap in my brain until we've managed to get all the signal out of our eyes coming off our brain. And there's just so much that's not touched. It feels foolhardy and stupid and like you read too much sci-fi, which is almost impossible to do, in order to think, oh, we got to drill holes. And I feel like I'm almost like a heretic for saying that. But you said non-invasive before I did. So why are you in the non-invasive camp versus, why shouldn't we all just go get a chip?
Well, I think because I'm realistic about most people are not going to breach the skull. They're not going to take a little drill through the skull. Neurosurgeons aren't afraid of drilling through the skull. They love it. They live for it. They train for it. And so they're the first people to say, oh yeah, it's no big deal, but they do it with a purpose. Now, I think that, there is this portion of your central nervous system, the brain, right? The only piece of your brain that sits outside of your skull is your retina. And so I'm obviously, I keep coming back to this, but I'm making a push for the visual system as an entry point for at least manipulating states and for accessing, this fear to courage transition, for accessing, control over stress in real time. I'm not an engineer. I'm not developing the technologies to do this. One of the reasons I was excited to come on your podcast is because people listen to it. I think that there are smart people out there that can create science-grounded tools for this.
Oh yeah.
And remember, that's a piece of the brain hanging out outside the skull for which the statistics and in other words, the stuff you want to deliver to the retina, then I don't injecting into the retina, I mean looking at stuff or seeing certain things is kind of known. It's not like you have to go find some substance in the Amazon. It's called light, and you just have to manipulate light either in VR or in another format in intelligent ways. And I think that but that is one form of brain-machine interface. Now, Halo is an interesting one too. I think the founders of Halo, one of them trained with Mike Mersnick. I've never tried the device, but
they came on the show. It was pretty cool. Yeah.
Yeah. I mean, it's grounded in very good logic. I received nothing from them, but I think that the logic is great. Stimulate so-called postsynaptic activity, activity in motor cortex while engaging in a motor task you want to learn better, get a little more or much more amplification of the signal and, learn things faster. It all makes sense. I think that the stuff that you're doing I haven't tried all the tools. I'd love to, next time I'm in Santa Monica, I'd love to try some of the tools and goodies and the pods and all this stuff. But I think very few people are willing to take an intelligent, thoughtful engineering approach to this. On the one hand, you've got scientists that are busy running their labs and trying to figure out how things work under normal conditions and solve disease and stuff. And then you've got people in the biohacking community who are like, well, what one pill is just going to get me there? And I think, I'm not just saying this because we're in conversation, I think embracing the brain machine, the non-invasive stuff, the supplementation stuff, the whole of it is the only way to arrive. It's a whole field, right? It's like saying the field of neuroscience couldn't have gotten by with just an electrode. You also need anatomists and molecular biologists. The field of biohacking and wellness, you need people who are thinking about different domains of the problem. And you're doing that. And there are others, of course, too.
You nailed it. When I created that community and in the term, in fact, they added biohacking to the dictionary in 2018 in Merriam-Webster's. It's a new word in our language.
Is your name in there?
Yeah, it is.
Are you serious?
I'm serious. Yeah, I was blown away. Someone texted
Next
me.
thing, so that I always say the moment you become a verb, then it's like Marie Kondo now. They're talking about like, you're going to Marie Kondo that. So pretty soon you're going to, we're going to call it bulletproofing it or?
No, it's just called biohacking. And I didn't trademark that word because I wanted there to be a name for like, how do we bring neuroscientists and Navy SEALs and, deep sea divers and weight loss experts and, all the people who didn't, and bodybuilders, for God's sake, like they would never talk to neuroscientists, but they're really, really good hackers of our human biology. And
well, they're willing to try most anything.
Yeah, we need guinea pigs who want to look like balloon animals. No, I'm just kidding. But like if you want to get real swole, but I wanted that, and you just hit it on the head when you talk about you won't get there with just one. Because I used to try just one of those when I had a lot of work to do because I was pretty much wrecked, and it kind of makes me mad when people like it's just that one pill. It's like, no, you can't eat garbage and take the one pill. It doesn't work, right? And if you just eat really cleanly and you think that's going to magically give you all the performance you can do, well, that's not going to work either. Like you just have to stack it, but then it's actually work. And sometimes maybe you need more arousal so you'll be inspired to do the work.
It's interesting because I think that right now we're at such a key point in the evolution of not just neuroscience, but this biohacking field. I think that it's no longer niche. And there are a number of scientists really, I heard a great podcast. It was with Rogan and David Sinclair on aging,
Oh yeah. I've been following David Sinclair's work. Some of the people who've shown some new things about nicotinamide riboside we're going to come on soon. So yeah. Okay. So yeah.
Yeah. I mean, guys like Sinclair, he was willing to at least talk about what he's doing in his own life. He cares about his longevity and his health. There's a new generation coming up and we're, I've been in this game a while because I got into it young, but we want to live long, healthy, better lives. I approached neuroscience and my career in neuroscience. I looked at it, I was like, look, I'm not a professional athlete, but like this is as competitive and time consuming and energetically demanding and potentially stressful as anything else. And it's professional. This is my livelihood. So my nutrition, my supplementation, my exercise, my whatever brain machine interface stuff I happen to play with, although I've done less of that, was all geared toward trying to be better at what I do, right? And live my normal life outside the lab. But so I biohacked my way through neuroscience. Like that's,
Yeah, but that's why, you have a position at Stanford because that came out really well in Game Changers. This last book, I asked 450 people who did something noteworthy enough to be on the show the same question and found the common patterns of what they did to become preeminent at what they do. And, Well, what you did to become at the top of your field is very similar. Like there's common patterns, and one of them is, in fact, the number one answer out of all these interviews when I had a statistician go through the data with me, it was actually food. Like, and a surprising number of people realize that when they eat crap, they just don't perform well at what they love to do, and then they don't. But then from there it goes all over the place, which is fascinating. So you somehow knew that. And I have two more questions for you. One is, how did you know to do that? Like, did you have weird parents who were, hippies giving you, drops of herbs? Did you have what? That's a rare human thing to just evolve into.
Yeah, honestly, it was because of a girl.
It always is.
It was. I mean, the short story of it is, I was a kid in high school, like skinny skateboard kid, and I was, there was a girl a couple of years older than I was, and I heard I might have a chance, or like she might have looked in my direction for a millisecond or something. I fell in love young, followed her off to college, and so I got into fitness first. I was like, all right, I'm going to start doing my push-ups and sit-ups and that kind of thing. And then, you get into that community, and pretty soon you discover like, oh, how I eat impacts my body and how I feel and how I think as well. And over time, I got really interested in nutrition and supplementation. I always wanted to try out different things. I found I do best personally on like limiting my starches and eating more fats. I was lucky that my dad is Argentine, so he was always like, look, you want to eat meat because it's important. Like, this was in the 90s, right? Because everyone's on these low fat, low protein diets. So, and I felt like I could outwork people, like in terms of longevity. Like in time, everyone else was crapping out, and I'm still going. And then I learned pretty early to use exercise to change my schedule. So if I need to be alert in the morning, I start exercising in the morning. I can shift on jet lag that way. And so I started biohacking early on. And frankly, I loved supplements. I think it taught me to be in tune with my body. I'm very sensitive. So
how many a day do you take?
Oh man. So the joke among my friends and colleagues is when people say, what do you take? My response is just all of them. I have the things that I take. If you looked at what I take, that most of them
I'm kind of thinking like it's going to be number, because I feel like I do 150 pills a day. So to list that would be the rest of the show.
Probably right? Somewhere in that regime.
Okay. But you take fistfuls basically.
Oh yeah. I mean, right. I mean, yeah, fistfuls easily. And I'm a big fan but I'm very systematic. So I've got my stack. I'm always happy to share that with people, but that's just what I do. I've got my stack, and then I systematically try new things. And I can tell very quickly if something doesn't work for me or works for me. Everything I get, you can get off Amazon is like typical. And so I don't take anything really esoteric, but I've long taken things like desiccated beef liver tablets.
Oh yeah, me too, for years.
Yeah, this kind of thing, like, I mean, multivitamin, ginger, these kinds of but so I eat pretty normally, except pretty clean. But I think in general, the supplementation has given me, I would say, it's hard to put a real number on this, but anywhere from like a 10 to 25% advantage. In terms of, I just look at colleagues and like attentionally they're dropping out. Yeah. Or like I see them like on for a meeting. I don't mean here at Stanford because there's some superpowered people here, but of course, but like on for the meeting, and then you walk away and they're kind of like, oh, you see them 5 years later, you haven't seen someone in like a year, you see them in a meeting, you're like, what happened? They're like falling apart. They're talking about their this pain and that pain. I'm like, I'm 43 now, and I put time and energy into it, but I think it makes me happier and it makes me better for my work.
Oh, the ROI on that is exceptionally high, and there's an infinite number of things you could do that would take all of your time, but over the course of practicing them, you figure out this one was worth it and this one wasn't, and that's the path of biohacking. All right, final question for you, Andrew.
Yes, sir.
I've been running an anti-aging nonprofit group, actually one that meets in Palo Alto for almost 20 years. And I've learned from people, 3 times my age, at least, well, back then, 3 times my age now, I was getting up there. But I've been real public in Men's Health recently. It's like, look, I'm going to live to at least 180. Here's the math. Here's why I think I can do it. And that's pretty far out there. But you're a biohacker. You're a neuroscientist. You're very well trained. You know what's going on up there. How long are you going to live?
It's a really interesting question. I actually believe, and I've felt this for some time, that 2 things. One is that we have a kind of intrinsic sense of how long that is without any intervention. I think we can sense it, although we have family history, so that gets in the way. I have a theory, and I am not, this is not grounded in any data that I've ever collected. But I have a theory that how protracted or prolonged your puberty was is a good predictor of your longevity. And now probably someone out there is like, so-and-so said that 20 years ago. Okay, yeah.
Mm-hmm.
I get it. I haven't read the literature. I haven't PubMeded this or in detail,
Okay.
but I occasionally take a look every once in a while. The men in my family have lived very long times. They age slowly. I hit puberty at 14, like many kids at that age, but it was very protracted in terms of the acquisition of what they call secondary sex characteristics, right? And I think that right now I'm aiming for 100, but I'm willing to expand that out. But this year on my birthday, I went up to Clouds Rest, this peak up in Yosemite, did my age and push-ups, and I plan to do that every year.
Nice.
I'm determined to prove that you can get better every single year because I feel better.
You can. Like, you can get younger. It's totally there.
I literally feel better, and I can perform better every single year. And I think there are levers to make that go better, of course, and you know more about that than I do. But but just to be optimistic, I'm going to say 120. And
all right, you just added 20 years right there. All right, that's what I like to hear.
Well, yeah, 120 because I feel that 100 is without intervention.
There you go. Okay.
Yeah, 100 without intervention, and I'm gauging that I believe that we have clocks that allow us to get some sense of how long we've got to go, barring accident or injury, of course. Right. Bus doesn't care about your genetics, right? Mm-hmm. You step on a bus, you're done. So if it's moving, and I'm not suggesting anyone do that, of course, the opposite. But I think that I think we have a sense of our arc, and I think the duration of puberty and the acquisition of the speed of acquisition of secondary sex characteristics is a interesting potential predictor of that arc.
Beautiful.
That's my answer.
Andrew, thank you for your work. You're doing really fascinating stuff across a diverse spectrum of neuroscience and neurobiology. And for people listening, you've got to check him out on Instagram. He has 1-minute neuroscience lectures. It's at Huberman Lab is where that stuff is. And I really appreciate both the depth of your work, but also the fact that you take the time and that you have the ability to share it in a coherent manner. Because there are a few neuroscientists, probably some guys you and I both know, who are doing profound work and they can't tell you what they're doing because they just, they don't have that in. So just thanks for being a good storyteller about your work and just for doing the actual hard stuff that you do.
Well, thanks so much for the kind words and for hosting me. I'm a huge fan of the work that you've been doing and are doing. And it's really, for me, it's very gratifying to get a chance to talk about these ideas with you and share them with your audience. So thanks ever so much.
If you like today's episode, you know what to do. Check out Andrew's work on Instagram at Huberman Lab. And while you're at it, if you like the show and you haven't had a chance to pick up your copy of Game Changers, I'm going to buy you 500 hours of life. If you were to listen to 500 episodes of Bulletproof Radio, which is going to take you approximately 3 months of your life working 40 hours a day, and there are quite a few people who've done that, but if you haven't done that yet, I went through every episode, gathered the knowledge from them, looked for commonalities, sorted through it, and made it so that you can read the book or listen to the book. You can read it in about 4 hours, and you can get all of that boiled down knowledge with the simple question is, what are the things you can do to perform better as a human being? Not by following one guru or another, but saying, what do they all agree on? What are the common patterns? So you can pick the things with the highest return for you. This took me more time to write than most of my other books. And it's not here's episode 1, here's what you learned. It's a real study of Bulletproof Radio. So check out Game Changers if you haven't. It's almost entirely 5-star reviews, the best reviewed book I've ever written. It just hit the shelves, and pick it up today.